right, guys, so we got our test coming up, so we're going to do a few problems off the test review. Remember, you are responsible for all these, and it is a grade, but the keys are in my room, and if you have any questions, you just need to let me know. The first one I want to look at today is number 2. Number 2 has multiple variables in it, but remember, we can use the swing method. We just have to remember to put that second variable into our answer. So let's just start off and imagine that the v's aren't even there and work it like we normally would. So we need to find the sum and the product. The sum is -8. The product is 5 times 3, so it's 15. So now I need to break apart 15 and see if I can get two factors that add up to -8. I could use 1 and 15, but that's really far apart and not going to work. I could use 2, wouldn't work. 3 and 5 look like a good option, but 3 plus 5 is +8. I need to be negative. But remember, two negatives also multiply together to give me a positive. So -3 and -5 are what I need to use. So I come over here. I have u -3 times u -5. Now, I'm not finished yet. That looks like a good answer, but I still have to divide by our a value, which in this case is 5. So I divide both my terms by 5, and I have to simplify before I can swing that to the front. 3 over 5 is already simplified, so I can swing my 5 to the front. I get 5u -3, but now I'm going to put my v back in on the second term. The other one, -5 over 5, can be simplified to -1, so I get u -1, but again, I need to put on my v. So it's just the same as what we've been doing, except for there'll be v's on the second term. Let's look at number 3 real quick. Now, this is basically the same problem, but remember, we always have to check GCF first. We didn't on the last one. I should have. But I need to look at my numbers, 6, 17, and 7. There is no GCF there, so I can just work it like normal. On the test, there will be a couple where you're going to have to take a greatest common factor first, and we'll see one of those in a second. But essentially, it's just like the last problem. I need to find the sum, which is 17, and the product, which is 6 times 7, so 42. So I start to break apart 42. 1 and 42 is not an option. That's not going to add up to 17. 2 and 21, also not going to work. 3 will go into 42 14 times. 3 plus 14 is 17, so 3 and 14 are my answers. So open up my parentheses, and as my variable, I'm going to say it's +3, and the other one's in +14, but order doesn't matter there. They could be either way. But I have to finish it just like the last one. In this one, my a is 6, so I divide both my terms by 6. Now, here's where people have been messing up. Just like I said on the last one, you have to simplify. Now, on the first one, I have 3 over 6, which is not simplified, but can be simplified to 1/2. I have 14 over 6. I can take a 2 out of both of those, and I get 7 over 3. Now that my fractions are simplified, I can swing my denominators. So my answer, when I swing the 2, I get 2n plus 1. On the second one, when I swing the 3, I get 3n plus 7. So remember to simplify before you swing. Let's move down to number 5. Now, the first thing we always want to try is GCF. Now, if I look at this one, the first clue is they both have an A. We can take out an A. But 3 and 27, I can take a GCF out of the numbers as well. 3 will go into both, so I'm going to pull out a 3. And then both of them have an A, so I can factor out an A, but to the lowest exponent in my problem, which is a to the first. So I can pull out a 3a. Now, I just have to divide both my terms by 3a. In the first one, 3a cubed over 3a, the 3's essentially cancel out. Then I have a cubed over a, gives me a squared. In the next one, the a's cancel out. I have 27 divided by 3, which gives me -9. Now, when you have to factor something out to start off with, you need to check what's left in your parentheses to see if there's anything else that can be done. I have a squared -9. It's a binomial. So if I have a binomial, I might check to see if it's difference of squares. In this case, it is. I have a squared, which I can take the square root of. I have minus because it's difference of squares, and 9 is a perfect square. So I'm going to keep that 3a. Don't lose it. The square root of a squared is a. So I'm going to open up my parentheses and put a in the first spot. The square root of 9 is 3. and one of them's plus, and one of them's minus. Does not matter the order. So remember to check GCF first, and then check difference of squares. Had that been plus, we would have been finished. The answer wouldn't have been prime. It would have just been what's right here. Let's move over to number 6. It looks like I have 12, 32, and 16. If you ever start off and your three numbers are all even, you can at least take out a 2. In this case, if you think about 12, you could have 2, 3, 4, 6. Well, 6 won't go into 32, 16, but 4 will. So I'm going to take out a 4. But all my terms don't have an end, so that's all I can take out is 4. So I'm just going to be dividing each term by 4. 12 divided by 4 is 3, and I'm left with n squared. 32 divided by 4 is minus 8, and the n comes down also. And 16 divided by 4 is plus 4. Now, just like the last one, I need to check what's in my parentheses and see if there's another option. And since it's a trinomial, we can use the swing method. So I look at my sum and product. My sum is negative 8. My product is 3 times 4 is 12. So if I break apart 12, I get 1 and 12, which there's no way I'm going to get negative 8 out of those, whether they're positive or negative. But 2 and 6 would give me positive 8. But if I change it to negative 2 and negative 6, I'd still get a product of 12 and then a sum of 8. So I'm going to move over here. I'm not going to lose what I factored out in the first one. I'm going to open up my parentheses. I have n minus 2 and n minus 6. But again, we're not done. We have to divide by a, and it's the a inside the parentheses, which is 3. So I divide by 3. We have to simplify our fractions, and I'm not going to lose the 4 on my next step. 2/3 is simplified, so I swing the 3 and get 3n minus 2. And 6 over 3 can be simplified to 2, so I have n minus 2. There's your answer. Probably one of the longer problems on the test. Make sure and check GCF. Number 7, just remember it is the swing method. Find your sum and product. This may be too big of a hint, but remember, if nothing works when you break apart your product to get your sum, then it could be prime. I would like to look at number 8. It's a pretty quick one. Remember, the first thing we always want to do is GCF, but I have 8 and 28. So it could be 2, 4, it could be 8. 8 won't go into 28, but 4 does. So I'm going to pull out a 4. And then both of them have a c, but the lowest exponent is to the first, so I can pull out a c as well. I divide both of my terms by 4c. Start with the numbers, then move to the variables. 8 divided by 4 gives me 2. C squared divided by c gives me c. Plus 28 divided by 4 is 7, and my c's canceled. Now, I always tell you to check inside the parentheses, but 2c plus 7 is simplified as much as it can be, so I can stop, and that's my answer. Now, let's go on to number 9. I'm going to change number 9. We've done a problem like this. It would be swing method. I think we'd be better off doing a different type of problem. The problem I'm going to put up here is x squared minus 9 divided by x squared minus 5x plus 6. Now, if you see a problem like this, the fraction may make you nervous, but this is exactly the same as what we've been doing. Just look at the numerator, try to factor it, then look at the denominator and try to factor it. Well, on the top, we have a binomial, so our main thing to look for is difference of squares. I have x squared, I have a subtraction, and I have a 9. We've seen this problem before, actually. So I can use difference of squares. Square root of x squared is x. Square root of 9 is 3. 1's minus, 1's plus. The bottom, guys, is just your sum and product again. Now, I'm not going to work out this whole thing, but if you do the sum and product, your sum would be negative 5, your product would be 6. And if I do that, I can use negative 2 and negative 3. So I have x minus 2 times x minus 3. And you can work that out. That's the exact same thing we've done on several problems. Now, what I notice is that I have x minus 3's on top and bottom, so I'm going to cancel those out. And my answer is what is left? X plus 3 over x minus 2. So don't look at that and think it's going to be horribly difficult, guys. You just need to factor like we have been and then cancel out where you can. We're going to talk about number 10 real quick. It's a binomial. There are no common terms. I could factor out a 49 and 121, but you should notice that 49 is a perfect square, so is 121 and c squared, and it's subtraction, so it's difference of squares. And if you're not sure, just push square root button in your calculator and check your numbers. The square root of 49 is 7, so it goes in the first spot. Square root of c squared is c, and I connect it to my 7. The square root of 121 is 11. 1 plus, 1 minus, and order does not matter. All right, so keep an eye out for those kind of things. Pretty much everything you saw there is something very similar to that is on the test. Let's go to the next page. I just want to point out, it looks like number 11 would just be a straight swing problem. Number 12 looks like it might be a difference of squares. And number 13, if you GCF, you might see a difference of squares. So practice those. I want to talk about number 14 for just a second. It is a straight GCF problem. I mean, we've never factored anything that looked like this. That should be your first clue. We're not going to be factoring it in the swing method or difference of squares. But let's look at the numbers. I have 5, 20, and 10. Well, 5 is the greatest common factor of those three numbers. All three terms have an x, but I need x to the lowest term, or to the lowest exponent, which is x to the first. And they all three have y's, but the lowest exponent in the y's is also just y. So I'm going to divide each of these terms by 5xy. Start with your numbers, then move to your variables. In the first one, the 5's cancel. I have x cubed divided by x, which leaves me x squared. Y squared divided by y leaves me y. Move to the next one. Negative 20 divided by 5 gives me negative 4. The x's cancel, and y squared divided by y leaves me y. Then I go to my next one. 10 divided by 5 is plus 2. X squared divided by x gives me x, and y divided by y cancels. So there's your answer. So if you see one that's got multiple variables in all the terms, because we haven't factored one like that, go ahead and just try GCF. Now there's several of the next ones that basically use the stuff that we've already been using. You just need to recognize when to use it. Like number 15, the area of a rectangle is represented by 4a squared minus 13a plus 9. And you have to remember the area, which they gave us, is the length times the width, or maybe if I wrote it like this, it kind of looks like the two terms we've been getting for some of our answers. So this question is simply do the swing method. Now, of course, we want to check for GCF. In this case, there isn't one, but we've already done some of the GCFs, or the swing method, so I think you'll be all right there. 16 is exactly the same thing. It's just talking about a square. If you remember a little hint I gave you in class, it might save you a little time, but I don't think that one's going to be too tough. Just use the swing method again. Number 17, we're going to do this one because it's pretty easy. It says the area of a piece of paper is 5p squared minus 13p plus 8, but it gives us the length as p minus 1. It says what's the width. So this is a division problem. I'm going to open up my 4 squares. In the top left box goes the 5p squared. In the bottom right box goes the 8, and that's from my area. The length, p minus 1, I'm going to put along the top. Now what I'm trying to find is two multiples, or two terms that I can multiply by my length to get my area. So I need to think what times p would give me 5p squared. Well, 5 would have to change the 1 to 5, and what times p is p squared is p. Now I go to the negative 1. What times negative 1 would make it positive 8? Well, to make it positive, it would have to be a negative, and 8 times 1 would give me the 8. So my answer is 5p minus 8. Now, I can check my answer by distributing that with my length, and if I get the same area, I'm correct. Now, guys, this checking thing could really help you on a multiple choice test, so I'd pay attention. First, I have 5p times p, which gives me the 5p squared. That's what I wanted. 5p times negative 1 gives me negative 5p. Negative 8 times p gives me negative 8p. And negative 8 times negative 1 gives me plus 8. So I do have the 5p squared and the plus 8, but I need to combine my like terms. So I still have 5p squared. Negative 5p minus 8p would be negative 13p plus 8. So I am correct. So my answer is 5p minus 8. So don't mess up that problem, guys. That's really not a bad one. Let's go to the next one. Number 18, we're just going to talk about for just a second. 18 and 19 are very much the same. It says the length of a square is 4x minus 7. What's the area? Well, guys, if I have a square and this side is 4x minus 7, like the length, that also means that my width is the same thing because it's a square. So this turns into the problem like we did to check the last one. we're going to have 4x minus 7 times 4x minus 7. So let's distribute. 4x times 4x is 16x squared. 4x times negative 7 is negative 28x. Negative 7 times 4x again is another negative 28x. And negative 7 times negative 7 is plus 49. So I combine my middle terms. I still have my 16x squared, but negative 28x minus negative 28x gives us negative 56x, and then plus 49. So there you go. Number 19 is the same question, except it's a rectangle, so the length and width are different. But remember, it's the same type of problem. You're going to take your two terms, 3x plus 5 and 2x minus 5, and you're going to distribute and solve. So you can do that one. Now, there are a few review questions on this test. I hope we've been working on them on the homework. We did one a lot like number 20 in a board work. Remember, it's just solve for R. I'm going to get you started on this one. Remember, we need R's on one side, numbers on the other. So I would add 9R to both sides first, because that would give me 11R minus 15 is less than or equal to 18. So you can move the 15 and then divide. Don't lose your inequality. Number 21, we've kind of been working on these. It's sort of like the GCF ones. What I'm really doing with this one is I have 12a to the fourth b minus 21ab squared minus 18a squared b to the fourth, divided by negative 3ab. So what you're going to do is really take the negative 3ab and divide each term by it. So it's kind of like when we were GCFing earlier. Go numbers, then variables. 12 divided by negative 3 is negative 4. A to the fourth over a is a to the third, and the b's cancel. Negative 21 divided by negative 3 is positive 7. A divided by a cancels. B squared over b leaves me b. And then the last one I have, I'm sorry, that negative should be on the other side of that line there. Negative 18 divided by 3 is negative 6. A squared over a leaves me a. B to the fourth over b leaves me b cubed. And there you go. So just remember to divide each term. Number 22, guys, it gives you some equations. You could solve those for y. You could plug them into your calculator. But if it's giving you x and y's, just plug some in. Like I'd pick 0 and 4 and start plugging it in for x for 0 and y as 4 and seeing if it gives you the right outcome. Like in A, if x is 0 and y is 4, that would be 0 minus 4 equals 2. That's not going to work, so A is not an option for our answer. And then go on. So use your calculator if you need to, but pick the easiest x, y. If one of them is 0, that's probably what you want to choose. And then the last one, number 23, I just want to make sure you're okay because it's not a hard problem. It says, what is the value of y when x is negative 3? That means plug in negative 3 for x, but when you're plugging it in, guys, you need to put it in parentheses. Oops, it's not squared, it's to the fourth. Now, you could put these each in your calculator, but I want the answer choice is going to be fractions. Negative 3 squared is negative 3 times negative 3, which gives me 9. Negative 3 to the fourth is negative 3 times negative 3, which is 9, times negative 3 is negative 27, but negative 27 times negative 3 gives me positive 81. And I could simplify that. Your calculator could do it by dividing out a 9 from both of them, and you would end up with 1 over 9. So guys, you are responsible for all these, but I've given you quite a jump on them. If you have questions, please let me know. Good luck.